Penske Shock is located in Reading, Pennsylvania. The company started in 1988. Well-known race car owner Roger Penske had the need for a more technically advanced shock for his IndyCar team, and that's where the shock company started on IndyCars. In 1990, we made a breakthrough into NASCAR and won the Daytona 500. And from that point, it really snowballed. NASCAR is our main market. It has been our main market since the early 90s, and from that market, we've seen a need for higher quality and more technically advanced shocks and other forms of racing, ranging from AMA, motorcycles, dirt cars, Indy cars, sports cars, all the way up to Formula One. In the early 90s, we were also tied into key Formula One teams. And since the early 90s, we have numerous world championships, Indy 500 championships, IndyCar championships, Daytona 500 victories, and NASCAR championships as well, just to name a few.
There's all these different markets, and each market needs specific ideas and need to solve specific problems. So each market we look at as an engineering team, and we try to think outside the box and come up with new ideas that will help that market. The nice thing about it is these ideas that we come up with in each market can help the other markets.
We supply NASCAR, all three series, the Sprint Cup, the Camping World Truck Series, and the Nationwide Series. We travel every weekend, and we work with just about every team. I'd say almost 100% of the teams on any given weekend, so talking about maybe 100 to 140 cars, depending on the event. We provide technical support, parts sales. We'll build for teams if they need us to. Gets to be pretty involved on many different levels.
Penske Shocks got into NHRA competition at the end of the 2007 season. We started working with one premier pro stock team that we got hooked up with through our NASCAR connections. After our 1 year was up with them, we went to the rest of the field. It took about 3 months, and we had 95% of the pro stock field. We went on to be undefeated in the 2008 season, undefeated in the 2009 season, and now we have pretty much every pro stock, 500-inch pro stock in the U.S. We won the 2008, 2009, 2010 championship, and now we're slowly getting into the ADRL world, getting into more of the sportsman racers, lower brackets. And we're a primary sponsor for the NHRA series, so we'll have track support, we'll have a truck and trailer, 4 technicians at all the races, so we can answer all the questions, help with car setup.
Penske Racing Shocks has been involved in the IndyCar market since 1988. At that time, it was kind of an exclusive deal with Penske Racing and under the development side. Since then, we are now working with all the teams at various levels, and we provide various levels of support. We're heavily involved at the Indy 500, that's where we have about 85% of the car count during the race. As well as IndyCar support, we also are heavily involved in high-performance production car market, which would include just about any type of car, from Corvettes, Vipers, Ferraris, but not necessarily those, even your Japanese imports, at all types of racing, which is from drag racing, autocross, just sometimes high-performance street cars, the occasional track guy. We're kind of bridging the gap from the racing components right into these production-based cars, and it's becoming very popular. These grassroots racers are becoming more aware and knowledgeable when it comes to damper technology, so and they want to acquire the same level of performance that say your big IndyCar teams or Rolex team has.
Well, shock absorber is just a velocity-sensitive device that basically reduces the oscillations with a spring and mass system. I mean, the most simple way to define it, you have an input put into a mass, and generally there's a spring. You have to have a way to dampen that oscillation, and that's essentially what what a shock absorber does. And obviously it's a lot more advanced than that, things we're doing. We're not just damping an oscillation. We tend to try to critically damp that oscillation, which is definitely a racing trait. More of a road car application, you're going to want a little bit less of aggressive damping. But it's really in its pure and most simple form is just to slow down oscillation and control the energy of the spring when it recoils.
A shock absorber is really just a hydraulic cylinder, and it has a separator piston, which when the shaft itself is displaced, fluid transfers from one side of the piston to the other, and it creates a pressure increase or force. And that's really all a shock absorber is a hydraulic cylinder. Now, as you'll start to see around our shop, how many different workings and pieces you can actually put into that hydraulic cylinder to create different curves, that's where the trick really comes in. But a shock absorber itself, it's a pretty simple piece. It has 2 chambers, one nitrogen chamber if it's a gas-charged shock, which is separated from the oil chamber, which houses your piston and your shims, which essentially affect your damping and the amount of force that you get in either compression when the shock compresses or in rebound when the shock extends. Now, as the shock absorber has evolved, we've learned to put different circuits on either side of that, which control your compression and your rebound, which make it now adjustable. And we've gone from a non-adjustable shock absorber back in, I'd say, the mid to early 80s to a single adjustable, double adjustable. We're all the way up to a 4- and 5-way adjustable shock now. And that really comes from engineering and race teams that are just finding new needs to be able to control their shock in different ways.
As a driver, shock valving, any part of the shock is probably the most critical part of the car in today's world.
That last thing that really is going to make the difference between you getting a pole or you winning a race, it comes down to shock absorbers. You know, being able to figure out what you need with the car, letting your engineers what you need, those are the small things that make the difference between winning and losing.
Penske Shock's design philosophy is really centered around what we do at the main piston. There's other companies that do basically make the shock a pump, moving fluid to different external valves. We've always done it where we do all our damping and our damping and curve characteristics at the main piston. We feel that's the best way to give the best response to the driver and the best handling car.
We're typically always looking for friction gains, friction losses, basically. We're trying to reduce friction. In any damper system, less friction is better, whether it's stiction or running friction, showing hysteresis. So we're typically looking at shaft coatings, bore coatings, different surface treatments, different arrangements of seals that we can measure frictional losses and things like that. We're constantly looking for new ways of reducing friction.
There's no right or wrong answer to having too much or too little with our shocks because they offer such a large range of adjustment. And that's the main thing that we really want to specialize in, is giving the customers the best possible product for the money, so they don't have to have 5 or 6 or 7 sets of shocks. They can have one set that kind of does everything for them. And at the end of the day, it makes for a happy customer and better product.
The advantages to the Penske philosophy on damping is some tangible and intangible things. There's a lot of driver feel is one of the big things that we focus on, and that's always the feedback we get when you do a back-to-back with Penske's versus another product that's not a shim damper, so to speak. But tangible results are what you see on the dyno and on the 7-post shaker rig. There's always enhanced grip values, there's always improved response from the damper, and hysteresis is kept to a minimum.
One question we're always asked is, why are the shocks expensive? There's a couple reasons. One, everything is engineered in-house. Everything is hand-built by a team of select technicians. We have about 15 technicians here that will hand-build the shocks. The shocks themselves are owner rebuildable. Every piece will be able to come apart, and you can add and take pieces away as needed. Whereas an OEM type shock is really a stamped piece of steel that's usually welded together, and if you crash or damage that part, you usually got to throw it in the trash and go get a new one. You can't rebuild OEM shocks. Where our shocks here, again, in 5-10 minutes you can disassemble them, reassemble them, and have a totally different damping curve in there. And the hand select people that build these shocks work on a one-on-one basis with the end customer on the type of setup that they need, type of tire wear that they need, and really specify the custom build that will go into that shock. Our shocks aren't mass produced. We don't have standard damping curves for everybody. It's really when you call us to order a shock, we get your background of your vehicle and what you want to do with the shock, and we will custom build that shock for your application, so you really have a one-of-a-kind shock and setup on your car.
Penske racing shocks are in a completely different level playing field than all their competitors. Mainly, the main is the people behind the damper, as well as the quality of the components. So all Penske racing shocks are hand built, hand assembled. They're machined from 100% from aluminum, all machined parts. So none of this stuff is mass produced. None of our product is cast or anything like that. It's manufactured to the highest levels of precision with the best possible materials for strength, durability, and quality. So when it comes down to the tolerances, is really what keeps them precise and repetitive, and that's what it takes to have a good race car and consistent lap times.
Finishes are a big thing, and finishing operations. So in terms of the hard anodize or our shaft finishes or what we do to the bores after anodizing, everything is done to make the damper perform efficiently and low friction and repeatable. So it's really based on the whole package, not one particular thing.
Shock absorbers play a big role in tire wear. Depending on the setup you have in the shock, it will shorten or extend your tire life dramatically. If you want to extend that tire life and be more consistent over the 3-4 stints that you might be running, you can do that. You build that setup into the shocks, and you'll notice your tire wear lasts a lot longer, or is more consistent over a long run, to where you're not having to purchase new tires every time you go out. We've always been so focused on professional, higher level racing. It wasn't until recently that we noticed higher end grassroots customers asking for the same technology, which is available on Corvettes, Dodge Vipers, Ford Mustangs, these type of cars that are raced every week at tracks around the United States. The technology that we have developed, that we use in Formula One and IndyCar and NASCAR, that's the same technology that we carry over and we use in our SCCA, our NASA, our time attack type cars, our everyday street cars. We use the same technology. The designs are all based off of needs in the racing industry. All the internal pieces that we continue to develop, it's always brought to us or thought of us of a better way to make a car handle and work. And when it does work, we like to spread that out to all of our racing series.
You know, the F1 guys were trying to solve a curbing situation where they're hitting a curb and they wanted the damping to blow off, which led to the development of the regressive valve. But then the regressive valve goes to other markets and is used in a different way, but that same technology helps all of our other markets. And in the other sense, our ATV market needed an anti-bottoming system for when they land jumps and things like that. So we came up with a hydraulic anti-bottoming system that, conversely, we look at using that new system that's patented and the new idea we came up with in things all the way up to Formula One. So it can go from the highest level down to the lowest kind of level, or the lowest level up to the highest level. it's really a good situation to be in.
Anything that we learn in F1 is translated to other areas such as grassroots type motorsport to pretty much all across the whole field. At the end of the day, it's a damper is a damper. There's certain things we can apply to everything we do in terms of performance, quality, and features.
Most of the professional teams have their own specific damper technicians or engineers that take care of the suspension on the car. What we're seeing in the grassroots type racing, it's typically a one-man show. The owner drives the car, he drives the transporter, he tries to take care of the car as well. And that's where Penske Shocks likes to go to the racetrack. We usually go with a transporter, 2 or 3 technicians, and we will help the end user, the customer, learn how to tune on their shocks, learn what tuning on the shocks will do to the car, what they should feel in the car, and really optimize their setup. And that's the same thing we do with professional race teams. We supply to IndyCar teams and NASCAR teams, to AMA teams, technicians at the racetrack that the teams can go to, ask questions about setup, and try to stay on the cutting edge of suspension technology. And that's the same technology that can be used in these grassroots type racing as well.
We have an electromagnetic dyno that we use here for a lot of our R&D work, from friction testing, like I mentioned, all the way up to track testing, actual track data testing, where the team will give us data as to exactly what the shock was doing on the track for an entire lap, and we'll bring that data in and actually load it into our EMA dyno and run the actual shock through the specific motions that it went through on the track. When we do this, we can analyze specific segments of the track to see what happened with the damper, whether it was reacting the way it was supposed to, and any kind of gains that we can make to make the car run better.